Hi everyone, welcome to my channel Student Brand, that is STB. Today we are talking about significant figures, rules for counting significant figures, class 11 CBSE physics. Here significant figures is nothing but in a measured quantity, significant figures are the digits which are absolutely correct plus the first uncertain digits. Those are called significant figures. Rules for counting significant figures. So, what are the rules we will follow to identify the significant figures? All non-zero digits. Non-zero means other than zero, like 1, 2, 3. So, digits are significant figures. Suppose example you take here. So, I'm considering example here. Okay. So 1 point, so 1.6, 1 to 126.28. So there is no zero here. So these all are called significant figures. See here how many are there? 1. So you can consider here 1, 2, 3, 4, 5. So 5 significant figures are there. Okay, 5 significant figures are there. So then it will be considered as, we can find out this is one rule. And the next rule is the zeros appearing between two non-zero, the zeros appearing, once again, the zeros appearing between two non-zero digits are significant figures. Two non-zero digits. So here you can take, so this is one and this is one, the zeros appearing in between these are significant digits, so we can consider as a significant digits. So here you can see there are 4 significant digits, significant figures are there, significant figures are there. So what are those? So you can take 6.025 or 78.078. Here how many significant figures are there? So 2 plus 3, so 5 are there. Suppose one more example you can consider 865.0078. Like this, how many? 6 significant figures are there. Like this example we can consider. Next one, here you take trailing zeros after decimal places are significant figures after decimal places. So here you can take, these are also we can consider after decimal places are significant figures. So these zeros also we can consider significant figures, because accuracy we have to add to this, like 0.001, like that. Then that also we can consider significant figures. After decimal places, whatever zeros are there, like 6.400, so here 2 zeros are there, or 7.80, so this also significant figures, are 8.20, this also significant figures, are 7 like that you can consider. So 7.230, this also significant figures we can consider these zeros. Here we are talking about zeros we are talking. Okay, so then, so here you can take examples. I already said it depends on accuracy. So measurement, so these are measurement. L equal to 6.4 centimeter. That accuracy, a least count is there, right? So that need to be added. So here if you are taking this rod, I'm considering this is the rod length, I'm considering here 6.4 centimeter. So if you measure 2-3 times, so you will get the measurements between 6.3 to 6.5. so if you add the least count, that is accuracy, to this 6.3, so then you will get, so 6.4, then there is a exact measurement will be considered. So here significant figures, how many are there? There are 2 significant figures are there. So here you can take 2 significant figures. And then next example you can consider this 1, 2 and 3. So in second example you can consider So L equal to 6.40 centimeter. So here accuracy, what is that? So 0.01 centimeter. That is also considered the least count. Until that much length we can measure accurately. So that is called accuracy, that is 0.01 centimeter. So if you didn't get the accuracy and least count, you can see my previous video, you'll get it, and units and measurements video too. Now you can see that length between. So after measuring, so we have to take 2-3 trials to measure this one. Then you'll get the measurements between 6.39 to 6.41. Then you have to add this least count also for the minimum one. So from minimum one you have to add, so 6.39 plus 0.01, 0.01, if you add 0.40 centimeters. So that's the reason in the previous one we can take so we got that one now definition also, and rule also we have to consider 0 also as significant figures. So here how many significant figures are there? So here 1 2 3. So 1 2 3, so 3 significant figures are there. So this is a closure. So after measuring this much in depth, this many times, is this much accurate, we will get the exact measurements of length. If you go more significant figures, we'll get more accurate of the particular length of the uh, whatever object you consider. So if you take a length of the rod, you can consider that rod measurement will get accurately. If you go on more number of significant figures, here you can see length equal to 6.400 centimeter. Here accuracy is I already said. So how many significant figures are there? So here you can take the accuracy also, that much centimeter it can measure. So here it can measure until this much accuracy, okay, until this much, okay, value it will measure. So if you measure 2-3 times trials, trial 1 trial 2, so you will get trial 1 3.9, so you can take 9, and the next one, next trials 6.40, and trial 3 6.39. So like that. So the minimum first point is, that is 6.33, 6.399. So for that you are adding the accuracy value, that is until the least count we can consider. This also considered least count, that we have to add for the value. Then we will get 6.33399 plus 0.001. Then you'll get the value 6.00 centimeter. That's the length, right? So we're using centimeter. Clear? So you got the clarity on it. So like that. Here how many significant figures are there? So previously we discussed here, right? So how many significant figures are there? There are 4 significant figures. So here you got 4 significant figures. So this is very closer, more closer to the exact length of the rod you can consider, right? So then going to the rule 4, the powers of 10 are not counted as significant figures. The powers of the 10 are not counted as significant figures. So here you will take the example, that is 1.4 into 10 power minus 7. So this cannot be considered as a significant figures. And even though, so 6.7 into 10 power 8 and 6 point, so even minus you can take, or 6.87 into 10 power 6, like this. If you take 10 power, okay, 10 powers, this cannot be considered as 10 powers, cannot be considered as a significant figures. So here how many significant figures are? 1 and 4 are 2 significant figures. So that's the reason, so we are taking 2 significant figures. So next one, rule 5, if a measurement is less than 1, if a measurement is less than 1, then 0.02, 0.04, 0.64, 0.78, so this is called less than 1. Then all zeros occurring to the left side of last non-zero digit, left side of non-zero digits. So this is left side of non-zero digits are not significant figures. Means here you need to understand. So the value, whatever the value of a particular measurement, if it is less than zero, if it is less than zero, as we seen here, so less than zero means from left side. So if you are considering from left side, so whatever the values, non-zero digits are not significant, non-zero digits are not significant, so these two are not significant, these two. So I already said, so this is the left side, so left to right, so left to right. Okay, so in this direction, if you are taking in this direction, these zeros cannot be taken as significant figures. So how many significant figures are there here? So two significant figures are here, right? So I hope you got it clear. Yes, to say what are those 4 comma 2. Here you can take, here how many significant figures? 1. Here also 2. Here also 2. Here also 2. Like that we can take. So these zeros cannot be considered as a significant figures, right? If the value, the condition is if the value is less than 1, less than 1. Remember this point. Very good. Next, change in its unit of measurement of a quantity. So if you change kilometer to meter, meter to centimeter, centimeter to millimeter, if the change in units of measurement, change in units of measurements, okay, units of measurement of a quantity does not change the number of significant figures. So significant figures cannot be changed. Best example I'm taking here, uh, L equal to 72 mm. Two significant figures are there. What are those? 7 and 2 significant figures. We can write this measurement in other without changing the number of significant figures. Without changing the number of significant figures. So here you can see 7.2 centimeter we can write. So 72 mm. So we know. So we can go with the kilometer. Kilometer you can take 1 kilometer equal to how many thousand meters. 1 meter equal to 100 centimeter. 1 centimeter equal to 10 mm. So like this we can consider. Here you see, so 7.2, so 72 mm given, right? So here you see 70 previous value mm. So 72 mm. Now you can see 7.2 centimeter. 7.2 centimeter. If you close the term, 1 minute. Yeah. Sorry, here it is meter. Here it is. Here it is. You can say. Okay, fine, no problem. Here it is meter, ma. So already we took this centimeter here. It is meter, right? Is like this we can take. How many I already said the value is less than previous rule, you know, right? This rule. So this rule we can take rule 5. If the value is less than 0, we will not consider the left side zeros cannot be taken as significant figures. So here it is less than 0, it is coming. So this cannot be taken as significant figures. Even here also you can take. So this cannot be taken as significant figures. So the value, how many significant figures are there? So here 7 and 2, here also 7 and 2, here also 7 and 2, here also 7 and 2. So like this cannot be taken as significant figures. So how many significant figures are there? Only two significant figures are there. Only two significant figures are there. What are those? 7 and 2, right? Yes. Next, the terminal or trailing zeros in number without a decimal point are not significant. That also sometimes arise due to change in unit. Okay, so here you can take, I'm considering here 264 meter is there, 264 meter is there. So if I'm considering 26400 centimeter, and also we can write mm. How we can write mm? So we can add 26400 mm. Okay, mm you can consider. So here, how many significant figures are there? Only three significant figures are there. Only three. So zero cannot be. These zeros cannot be considered as a significant figure. So here, the terminal are trailing zeros in a number without a decimal point. So terminal means end. So we can take this is the starting point, this ending point. So this is the terminal point, ending point. So these zeros cannot be considered as a significant figures. So whereas due to change of units, after change of units we cannot. So here how many significant figures are there? Three are there. So here for two more zeros are coming, sir. So then we can take five significant figures. No, okay, we cannot take. Here we have to take only three significant figures, right? So that is the rule number 7. Here also how many significant digits are there? So significant figures, those are 3, right? Fine. Next, rule number 8. Exact measurements have infinite number of significant figures. Nice, great. So here, if you take pi value, we can take a 3.14. So actually this is not exact value, still it is continuous, it will continuous. So that is the reason. So we can't take even speed also, speed of the light you can see, so this much it will be there. So but it is still it is will be there. So that is an exact measurements have infinite number of significant figures. So all these measurements have infinite number of significant figures, right? So this is about today's significant figures and rules for counting of significant figures. So that is today topic. Thank you so much. So please do like, share and subscribe. So and do like, so I will get no motivation to do, to get, to teach, to elaborate subject in more depth. I will reach out to you for your queries and doubts if you comment below. Thank you so much. Your student, the brand STB.